work? Who knows? It's also what I thought I did yesterday and it didn't work, so. Well, actually it did work for just a brief moment. But anyways. All right. Nothing to it but to do it, right guys? Okay. Oh goodness, September 12th. Oh, Wednesday already? Crazy. If you weren't here or you didn't get a term schedule last day, put your hand up. Okay. For some reason, I can't figure out how to close this little guy, but that's okay. So I finally figured out, okay, so I can't project and record at the same time, fine. I'll have my phone join in as a participant and project my phone. But I've had some bad luck with messages popping up during class. Not as bad as it could be, but not great. Well, I did that yesterday. I guess it only works if the screen's locked. So, oh, I tried that this morning. So hopefully, I'm not expecting any messages, but who knows? You guys will be forgiving. All right, so the cost of being hip and happening, I guess. All right. So we started off last day with some real stuff, right? And it was just on Monday, so hopefully we kind of remember. But we talked about variables, right? So just as a little bit of review, I don't know how I like this incline here. But we talked about variables. There's lots of different kinds of variables, but we're going to be concerned with whether a variable, remember a variable is just a column in a spreadsheet, right? So it's any sort of data that we've collected. So variables can either be categorical or numerical. Okay. So categorical variables are ones where the data can just be put into categories, right? Hair color, species, things like that, right? Gender, those are all categorical. And then numerical variables, right? Those are all the measurements, right? So where data can take on any value, right? So things like distances or speeds, right? Heights, lengths, any sort of measurement, that's going to be a numerical variable. Okay? Even things like age, we talked about they're whole numbers, right? But still numerical. Okay? From numerical data, we can make categories, right? But at its core, we've collected numerical variables. Okay? And then we talked about the response variable versus the explanatory variable. Right. So if we have a research question, right, a goal of what we want to study, and I think we talked about the heights of males, right? And so we want to know what's the average height of males. Then we collected a study or a sample, I should say. And we don't just collect the heights, right? We collect other things as well. But the height is the main event, right? So that's our response variable. And then all the other variables are explanatory variables, right? So that's the one that we're trying with the explanatory variables. We use those to try to help predict what's happening in the response variable. Right? Sometimes they help, sometimes they don't, right? But regardless, they're going to be response variable or explanatory variables, sorry. We also talked about data collection briefly. And I said, we're not going to go too deep into it, right? But the take-home message was, well, if we want to say something about the whole population, right, we have to take a sample of that population that's actually representative of that population, right? And the only way to get that is to have a random sample, right? So we need random samples to have a sample that's representative of the population. So we need to have a sample that has been randomly selected in order for it to be representative of the population. So that's kind of our review for today. We started off kind of a little bit slow, but a lot of terminology, right, that we kind of need to keep track of. Okay, so we'll call it 1.4 is new now. We're going to talk data collection. Again, not too much, like I said last day, because we won't be focusing on it too much. All the data that we're going to use, we're going to assume has been randomly selected, and it avoids all kinds of bias that we'll talk about now, right? And so we'll assume that we have good data, but we still have to talk about these things. So for data collection, I think if you're imagining yourself collecting data, you're probably thinking a survey of some sort, right? You go out and you ask people, how tall are you? That kind of thing, right? So surveys are a common form of data collection. And I'm a sucker for surveys. Not that I love doing them, but I used to work for a market research firm, and it is just the worst waiting for people to do your survey. So I always just do it, help them out a little bit. It's brutal out there. No one wants to do surveys. So I encourage you, next time you get a survey, maybe do it. Do every other one or something. Okay. So surveys are way harder to make than you think. Okay. Especially, well, if you want to do it properly, right? Because I've seen so many surveys out there that don't really, the data that you're collecting isn't actually going to answer the question that you think it is. So that's a problem, right? So if you ever have to make a survey, good, give it a go, right? But maybe consult with someone who knows what they're doing, right? Or take a surveys course. So the hardest part about surveys is that no one wants to do them, right? And so you have this target population that you want to get at, right? I feel like I'm blocking this side of the room. I guess it would be pretty awkward walking past. Right, so you have a target population that you want to get responses from, and so you send out your surveys and you only hear back from a few of them, right? And so surveys are tricky because you will only hear back from a small number of people in your target population. From a small number of people in your target population. So that's a problem, right? So if you need 100 responses, for example, then you can't just send out 100 surveys. You know that you're only gonna get back a select few of those, right? So as a general rule, you send out 10 times as many as you are hoping for. And even then you might have to send out more, right? Because it's hard to get responses back. So to make sure you get a large enough sample, or a large enough sample, send out approximately 10 times as many surveys as you need back, just as a general rule. Okay. Sorry, writing is kind of tricky on this thing, but I like standing. Way funner. So here, usually we refer to the sample that we're kind of working with, right? The data sample. Technically, in this case, we have a target population, let's say students at the college, right? And then your sample in this case, and this isn't that important, your sample is actually the original mail out, meaning the original people that you've contacted to ask them to do the survey. And then your responses is the actual surveys completed. So here, when I said to make sure you get a large enough sample, I really mean large enough number of responses, right? But later on, when we're analyzing the data, it becomes your sample. So that's confusing, but I wouldn't worry too much about it. Okay. So if you're doing surveys and you've contacted all these people, you've asked them to do the survey, only a few of them get back to you, then it's important how many people actually completed the survey out of how many tried to contact, right? And so we talk about our response rate. The response rate is the number of responses divided by the number in the sample, right? How many did you get back out of how many did you send, right? So we care about the response rate, right? Because if you send out, I don't know, I had an example here, 250 surveys, let's say, then if you get 200 back, that's really good, right? If you send out 15,000 surveys and you get 200 back, that sucks, right? You still have 200, but your response rate is way, way lower, right? So you tried to contact 15,000 in your population and you only heard back from 200. You can't really draw any conclusions from that, right? Because you've got such a small proportion of your target population. So we have to report our response rate because it communicates how reliable your data is. Okay? So it is important to report the response rate. So if you're reading reports and stuff like that, there should be a response rate. Okay. Since 200 out of 250, bless you, is a great response rate, but 200 out of, let's say, 15,000 is a terrible response rate. Okay. With a low response rate, we won't be able to draw reliable conclusions. We won't be able to draw, reliable conclusions. I'll say about the population. About the population. That's a problem, right? You've tried to say something about the whole population and then you get no responses back. So really, you can still analyze that data and you can still put out predictions, but you have to mention the response rate and say that, well, because of this low response rate, there's nothing we could do about it, but these results aren't as reliable as we wanted them to be.
So it communicates the reliability of the response or of the population?
Of the data that you've collected. Yeah. So when we talk about, the heights of males at the college, for example, right? Then if we put out a survey, let's say to 500 males, and we only hear back from 10 of them, right? We can still collect their heights and we can still find the average of those heights, but we're not very confident in our findings, right? It's the best thing that we could do. We tried to get more data, right? But we couldn't get it. So it's all we have, but we have to recognize that it's not very reliable, right? So, any questions so far? It's pretty sad. A 10% response rate is okay. I mean, the higher the better, right? That's why you see all these kind of things that they tempt you with, right? Win an iPad or win a trip or whatever to boost the response rate, right? That's the goal. So yeah, I'd say 20% would be really, really good, but you'll never see 20%. Uh-oh. Don't fail me now. Oh, goodness. Okay. Hello. Oh, okay. It's okay. I think. Why would it die, I wonder? Weird. It's like Who knows this thing? Okay, hopefully it's still trying to record. It might have cut out there, but I'm gonna count it as a win. Okay, we'll see. Okay, so that's surveys. So let's talk about, how do we collect surveys properly? First, let's talk about some bad survey techniques, or just bad sampling is what we're gonna call it. Okay, so let's talk about bad sampling. Get it out of the way. These are just things that we need to keep in mind if we're ever collecting surveys, collecting data, right? So bad sampling at its core is going to be any data that's biased, right? Now, it's practically impossible to have completely unbiased data, right? For example, we send out surveys, we have response bias, right? People who don't respond, we don't hear from them, obviously, right? So we're only hearing from people who do surveys. First off, that's a problem, right? But in general, bad sampling is any sampling that is biased. So by definition, bias is systematically favoring an outcome, okay, just in general. So systematically favoring an outcome. Okay. So, for example, we have things like voluntary responses, right? If you go to a website and you've asked a question or whatever, and it says, hey, was this helpful? Yes or no? And you just hit your yes or your no, right? You're volunteering that information. Facebook asks you, hey, do you want to do this survey? You're volunteering to do it, yes or no, right? So we have things like voluntary responses. It's kind of a problem, right? Even if the college contacts you and says, hey, can you please do this survey? You're still volunteering to do those, right? Or things like convenience samples, where, someone's out in the courtyard here and just trying to collect information, or if they're just standing here outside our room and tries to catch everyone as they're coming out of class to do a survey, right? That's only people in stats and whatever's going on in there, right? And so they're not really capturing the whole population. And in the courtyard, right, might seem safe, but if you're there in the morning, you're not catching the afternoon people. So it's a lot of problems, right? So those would be convenience samples where you're just collecting where you are or where it's easy to collect data, right? And so that's a problem. Okay. So some other things to avoid or just be aware of. Okay. Some other things to avoid, be aware of. A lot of the time, there's nothing we can do about it, right? There are only a few ways that we can collect data, right? And so we just have to be aware of what the problems could be and address those in our report. Okay. Things like with surveys, things like under coverage, right? You haven't reached a certain population or even been able to ask them to do the survey. So for example, if you're doing phone surveys and you're calling landlines only, Then you have huge undercoverage. There's a lot of cell phone only households. Don't worry, you can buy cell phone numbers or just random digit dialers. So, you know, when you get those calls, but they have the same area code as you do, right? I get a call from a 250-864 number. I'm like, oh, fun, a Kelowna number. Hello, you have reached. So then they get your number and they just call you from a number that's similar, hoping that you'll pick up. But a random digit dialer is just, it sets those first, I guess, 6 numbers, and then it just creates 4 random numbers, calls it, sees if anyone's there. Which is pretty cool, but also annoying. We've talked about non-response. Just not hearing back from, so people that you could reach, right? Tried to reach, but then they didn't get back to you. Okay, that happens. Response bias, I'd say happens a lot, right? Depends on what the survey is about. So even if someone does do the survey, right, and let's say an iPad's on the line, you don't want to give negative responses, for example, right? Or if it's a political pollster, right, you just tell them that you're voting for them so they leave you alone. Happens a lot, right? And so response bias, nothing we can do about that really. Okay. But we can keep in mind things like even the wording of a question can alter the responses, right, and create some bias. So we have to keep an eye on the wording of questions, but also question order. So even in your survey, you got someone, you lock them in, they're gonna do your survey, and then you just haven't made a very good survey, right? There's gonna be questions that are worded kind of strangely, or maybe putting people on edge, depending on what you're talking about, right? And so they're gonna respond with bias, right? Or even the way you order your questions could put people in a biased direction. Okay. So I have a little example here that I wanted to not write out. Okay, whoops. You guys read that? So there's typos in here, but they've been in there for years, so I'm not changing them now. So how do Americans feel about illegal immigrants? Kind of hot topic right now. Should illegal immigrants be prosecuted and deported for being in the US illegally, or shouldn't they? So they put this question out, and 69% of the sample favored deportation. Yikes. Okay. So then they took the exact same group of people and they asked whether illegal immigrants who have worked in the US for 2 years should be given a chance to keep their jobs and eventually apply for legal status. 62% of those same people said, oh yeah, that sounds good. Right? So that's crazy, right? So 69% said, oh yeah, deport them. And then 62%, there's a lot of overlap there, right? Said, well, oh yeah, they can stay. That's fine. Okay. Things like government help for the poor. So only 13% think we're spending too much on assistance to the poor, but 44% think that we're spending too much on welfare, right? So these are things that we have to kind of keep in mind when we're wording surveys, or even reading survey results, right? Because, well, what was the question, right? What order was it asked in, right? Because it can make a huge difference. What can you do? All you can do is do your best. That's the, right? You can turn surveys whichever way you want. So I don't consider them too reliable. And at one point I made a living off surveys. So I guess I know then. Okay. But just something to keep in mind, right? And I think we hear it on the radio all the time, right? I hear stats that they're throwing out there, and I'm kind of like, well, yeah, but what about this, right? So part of this course is just making you aware of these things. Okay? So let's talk good sampling. What is good sampling? How do we get there? What does it mean to do our best with sampling? We already talked about it. Right? And a randomly selected sample, that's a good sample, right? And so whatever you can do to make a random sample, that's great. So good sampling is just a randomly selected sample. Okay. So at its most basic form, or just a plain random sample, we call it a simple random sample. Okay. So a simple random sample abbreviated SRS, and you'll see that throughout the term, right? An SRS. So you're studying manatees and you collect an SRS of 50 manatees, right? That's just telling you that this sample was randomly selected and it was a simple random sample, meaning you had your population in front of you and you just picked a few randomly, right? And so a simple random sample is, is the most basic random sample we can collect. Oops. This doesn't look like can. Okay. There's more complicated sampling that we could do, right? Some of which are stratified random samples. So where we have distinct groups or strata in our population, right? Think BC, right? Regions. So you want to get some number from the lower mainland. You want to get some number from the Okanagan Kootenays. You want to get some number from the island, some number from the interior, right? And so there you've divided your population into strata, and then you do random sampling within that strata or within each strata. Okay. So more sophisticated sampling would be things like a stratified random sample, where we divide the population into groups or strata. Okay. And sample randomly. Within those strata. Oops. So that's stratified random sampling. And that just ensures that you have, so the population of BC, right? We have some percentage living in the lower mainland, right? That's a huge percentage. So you want to get a percentage that's representative of that area, right? We wouldn't necessarily get the same number of responses from each of the regions, right? We would get a representative number of responses from each region, right? But it's just to make sure that you get enough people from the interior, for example, right, in your sample. Okay. Or there's something like multi-stage sampling. It's just stratified random sampling, but you divide, so first you've divided BC up into its regions, right? It's different strata. And then within those strata, you divide people into males and females, for example, right? And you sample a random sample of females from the lower mainland, right? A random sample of males from the lower mainland. So it's just multiple layers of simple random sampling, essentially, right? So, oops, dividing each strata into stratas. Stratum. Okay. So these are things that we need to talk about, and I'm not too concerned with them because there's way more sampling techniques, right? I just need to expose you to some of them so that when you hear random sampling, you think, oh, that's good. Okay. So, any questions so far? Okay, so there's two ways that we can collect information, right? We have been talking about what we would call an observational study, right? Where we're not influencing the responses in theory, right? We're just asking people, hey, how tall are you? What do you weigh? Right? What's your hair color? Things like that, right? So those are just observational studies where we're just observing information, right? And the other type of data collection that we could do would be experiments. We're not going to talk too much about experiments, but let's just outline them here. So there are two ways of collecting data. First one is through observational studies. Things like surveys or just sampling random people. Or user data, right? If you run a website, for example, then you get user data, right? What did they click? How long did they read that article for? Kind of gauges engagement in the article, that kind of thing, right? So we don't influence that, we just observe and then try to draw conclusions. Okay. And the second one we said was experimental studies. So experiments are, well, I think we kind of know what an experiment is. An experiment is where we control all the factors, right? Or we should be controlling all the factors. And it's the only way that we're able to say that, hey, this fertilizer, for example, causes an increase in growth in this plant, right? So experiments are the only way that we could develop a causal relationship. Okay? So, oops. Section 1.5 is on experiments, and we're just going to get in and get out because experimental design and experiments itself, I mean, that's a whole degree if you want, right? So we're not going to go there. Okay? But what we need to know from experiments is that experiments are the only way to establish a causal relationship between two factors.
Does the causal relationship mean that the two factors depend on each other?
Yeah.
Like reaction?
So a change in one causes a change in the other, right? So an experiment is the only way that we can say something like that. Okay. So that is a change in A causes a change in B. We can't say that with observational studies. Even if the two are strongly linked, we can't actually say anything. Okay. So this is assuming that in your experiment, you've controlled every little aspect of the environment, which is hard to do, right? So assuming you control every aspect of the experiment or of the environment in your experiment. That's a big assumption. Even if you're working in a lab, right, and you've got tomato plants, let's say, right, and you got a bunch of pots, and some of them get X amount of water each day, and some of them get this amount of fertilizer, right, and you've got these, I don't know, grow lights over, right, but then some of them are closer to the window than others, right, that would affect it. So you'd have to have a completely controlled environment to be able to say that this causes a change in this. So it's very hard to do. So we just kind of skirt around it most of the time. Yeah. Okay. Any questions about that stuff? So this stuff would be mostly kind of multiple choice questions on the first test and then later on the final. Right, so just kind of quick, do you remember what we talked about? Multiple choice questions, right? Because this is all theory and not really anything to do, right? Now let's move into section 1.6 is where we go back to our data that we've collected in theory. We assume that it's randomly selected. And now we're going to start examining numerical data. Okay. So we've kind of gone through how do we collect data, right, properly. And now we're going to start assuming that we have good data. Now what? Right? We have our spreadsheet in front of us. What are we supposed to do with it? Right? We can tell people what kind of variables we have. Oh, I've got like 60 response or explanatory variables. Oh, wow, that's crazy. Yeah, I know. Got like 2 million responses. Wow, insane. Things like that. So the first thing that we do is just kind of start exploring our data set, right? We want to get a kind of a quick overview of what does the data look like, right? So the first thing that we do is we start visualizing the data, right? That gives us a quick overview. We could generate some numbers right away, but oftentimes it's easier to just visualize the data. What's going on in here, right? And so once we have a data set, we will want to examine our variables to get an idea of what they look like. Of what they look like. Okay. So for that, we do what's called data visualization, or data viz, as we call it in the biz. Okay. So data visualization data viz. Okay. It just provides a clear kind of summary of what's going on in your data. Okay. So it provides, I'll say a quick / clear summary of your data. Okay. So one thing to remember with data visualization is that it should be just so clear that you don't need to explain anything. And that's hard to do, right? I think because you get so familiar with what your visualization is, and then you go to present it, and then you find yourself having to explain, oh, well, this color means this, and this bar means this, and so we need to remember that just clear, concise, quick, right? No words, ideally, right? For example, something like this little guy here is very good data visualization, or data viz, courtesy of the good folks at Facebook. I think we can all kind of, if I said Facebook at the top and I showed you this, I think we can all kind of say, oh, I get it, right? We can look at this and say, oh, wow, lots of connections happening here, right? Not as many happening here or here, right? And so that's the idea with data visualization. We just need to look at this and say, oh, well, I get it. These are all the Facebook connections in this part of the world. Right? And so this I would consider excellent data visualization. It's not fair, their data was too simple. Well, it isn't, it isn't. Looks good. Okay. So I'll just write a little note here. Oops. Oh. Okay. Don't worry, I have an example of kind of bad visualization that I stole. Okay. So something like this, right? And it's easy to get caught up into making something like this, right? Because like I said, you're so entrenched in your data and you know what's going on and you're trying to communicate all these things, right? And it turned out beautiful, but then your boss has a look and says, so what's going on here, right? Well, what is going on here, right? We've got so many different layers. We've got this kind of root bubble here, whatever that is, right? Do the distances from the root bubble to the actual bubbles, does that matter, right? Does that communicate anything, or are they just there? The size of the bubble, I'm assuming, means something, right? The color of the bubble has to mean something, right? And so we've got all these different things that we're trying to get out there, but we're failing miserably, right? So you want to try to avoid doing something, although cool, right? That's not the goal of data visualization. Right? So, good data visualization, good data viz is clear and simple to understand with very few words. And data viz itself is a very exciting field right now because there's a lot going on, with big data and stuff. And so Twitter is producing some pretty cool stuff. Facebook, of course, they're putting out some pretty cool stuff. And so the data viz world is evolving right now, which is really cool. So we've been stuck with these kind of go-to data visualizations. You've probably seen a pie chart, probably a bar chart at some point, right? Maybe a histogram. We'll talk about histograms. Okay, but those have been kind of the go-tos. Those are unfortunately the only ones that we'll talk about in this course. It's all we really need, but there's a lot happening right now, so it's pretty cool. Okay. So for our variables, remember we said, okay, we can either have numerical variables, or I guess I had it on this side, categorical variables or numerical variables, right? So depending on if we have categories or measurements, we need to treat those differently, right? And so we'll start talking about what do we do if we have a numerical variable. Okay? The only option for us in this course is going to be to make a histogram. Okay? So to visualize numerical data, we will use histograms in this course. Okay, so I'll pull a little example histogram. Oh, I better keep the title there. So something like this, right? And so remember, we're dealing with numerical data, so these are all measurements. For example, how tall are you, right? We've got a list of heights. And so histograms, what we do is we make what we call bins, okay? And so imagine if you take all these people, so everyone in your sample, and you say, okay, if you're between, well, 10 and 15, I can't think of a length that's like height appropriate. let's make it age instead, right? You have a group and you say, okay, if you're between 10 and 15 years old, please line up over here. Right? If you're between 15 and 20, or 16 and 20, I guess, line up over here, right? So you get these lineups, and so you put people, even though these are measurements, right, you put them into bins, and that's how we generate this histogram. So the height of each bar just indicates how many people fit into that category. Yeah.
So what's the difference between histogram and bar graph?
Good. Hold that thought. So, well, I'll just tell you. So a bar graph is going to be the same, right? Except the bars will be completely separate because each bar represents a category. So they look the same-ish, but they're going to be very different because here we have a continuous scale, right? And whereas bar graphs, when we start looking at them, they'll have distinct categories for each bar. So yeah, they will look similar. Cool. Okay, so we have, let's say these are ages, right? So we've got very few people are in our 10 to 15 lineup, a little bit more people in our 15 to 20 lineup, 20 to 25, pretty popular age, right? 25 to 30, extra popular age, right? Line up out the door. And then we start tapering off, okay? This bell curve that we get here is so common in nature in general that we call it the normal distribution, okay? And so we get this kind of bell shape, right? And so the most common shape of a distribution is a normal distribution. And I make an effort to write it with a capital N because it's a name, right? So we call it the normal distribution, okay? It's also called the Gaussian distribution for Gauss, who figured it out. But I mean, normal just sounds better, right? And so the normal distribution is, oh, that was terrible. This kind of bell shape, right? So we have a bell shape normal distribution. If you think about even things like speeds, right? If you're testing a car, for example, in a certain amount of time, then you're going to have very few slow ones, and then most of them are going to be lumped around the middle, and then they kind of taper off, and you've got these extreme fast speeds, but not very many of those recorded, right? And so it's kind of like a natural phenomenon. Almost everything follows a normal distribution. Okay? And so I think that's pretty cool. Good. I should probably do that. Oh, it's on both screens. Oh, wow. Okay, so throughout this course, we're going to be doing a lot of work with this normal distribution, right? Because it is so common in basically everything that we deal with, right? And we're going to be concerned with mostly numerical data in general, so. Okay. I'll just touch on some non-normal distributions. Okay. I won't go into it in detail. If you go, if you're in psychology, for example, then we'll spend half the term talking about different distributions and different things to do because it's more important. But for us, I'm just going to touch on the basics. Okay. So some non-normal distributions include, if you get something that looks like this, okay, or something that looks like similar but the other way around, these are both, oh, come on, these are both skewed. Should hold on. Okay, so this one, the first one, is skewed to the left, which I don't know about you, but for me, this top one, right? As I think it's pretty human to want to talk about where the bulb is, right? But here in stats, we're going to be concerned with, yeah, everyone's over here, but what's going on over here, right? And so we want to talk about the extreme values. And so that's why this top one is skewed to the left, because the tail is going to the left, and that's going to be the one that we're going to be concerned with, right? We don't concern ourselves with what everyone is doing or what the majority of people are doing, right? That's fine, but we're concerned about the tails, okay? So here, we could also call it a negative skew if we wanted to. Which means that this would be skewed to the right. Or a positive skew. Okay. So it's skewed in the direction of the tail, right? Or the more extreme values. Okay. So going back to the normal distribution, we're actually always going to try to argue that we have a normal distribution, right? The reason being that the normal distribution opens up a lot of calculations that we can do that we can't actually do if we have a skewed distribution, right? So we will always argue that we have a normal distribution unless it's completely obvious that you don't, right? So we will always argue that we have a normal distribution. I'll say unless it is very obvious that we don't. We can also have another non-normal distribution would be a bimodal distribution, trimodal, where you have two very distinct humps in your distribution. Okay, so this would be a bimodal, I think it's one word, distribution. We won't be dealing with those at all. Oops. So if you think you're seeing a bimodal distribution, you're probably not in this course. Okay. So. Okay. All right. So once we have our normal distribution, right? So we have back to normal distributions. I'll be using the word distributions a lot, right? But what we're thinking in terms of, right, an example here, this is the distribution of ages, right? So we're going to have distributions of our data, right? It's going to be normally distributed or non-normally distributed, right? So we're going to talk a lot about distributions, right? Mostly normal distributions. Okay. So normal distributions, remember, not that beautiful. The idea when you're drawing these curves is you start with a line and it starts off slow and then it builds up and then it kind of tapers off. They'll never be beautiful, okay? But the idea is that there's actually room in these tails and these tails continue forever in theory. Okay? So I don't want to see stuff like this. That's no bueno. Oops. Okay, here's my second shot. Beginning a term, it's going to take some practice. It's okay, you'll get really good at it. Okay. So now we've visualized our distribution and we have something that looks like this, right? Even without the line on here, I think we can all kind of just look at this and say, okay, well, if I smooth this out a little bit, I would have a normal distribution. That's how I would describe it, right? And so we can kind of imagine this normal distribution happening, right? So to fully describe a distribution, okay, so to describe a distribution completely, okay, we need to talk about or discuss, we need to discuss three things. The first one being shape, right? That's the first thing that we see. Okay? So the first thing is going to be the shape, right? We really only have two choices. It's either going to be normal or we're just going to say it's non-normal, but it won't be. It'll always be normal. But in general, our choices are normal versus non-normal. Okay. The second thing we want to talk about is the center, right? What's the most common value in this distribution? Okay. And I'll pull this old thing, if I can. Oops. Sure, that works. Yeah. No. Okay. I'll just steal it again. Oh, but again, I need this. Oh, there we go. Here we go. Okay. So if this is your distribution and I ask you to describe the distribution, you know that the first thing we have to talk about is the shape. Well, you say you have an approximately normal distribution, or you can just say normal, right? I like to throw the approximately in there if it looks a little rough, right? The center, right? The center would be just the most kind of roughly the most common bin, right? So the center, for describing the distribution, you eyeball it. You just look at it and say, okay, well, roughly 25. Right? I would accept anything between 20 and 30. Right? You don't have to spend a lot of time. You could say the center is between 20 and 30 if you want, right? But in general, we're just going to eyeball it. Oops. Okay. So if we're describing this histogram 1, then we would say, okay, the shape is the first thing that we have to talk about. We decided it's, oh, what the? It's normal, right? Or if you want to say approximately normal, it's fine too. The center, I'll say it is around 25. Okay. Or if you want to say something like between 20 and 30, it's fine too. Okay. What you want to be looking for when you're eyeballing the center, right, is if you draw your curve, where would the peak of it be? Right. It's not necessarily the highest bar always, right? The highest bar could be a little bit off, right? But just in general, where would the center of the normal distribution be? And then the third thing that we would want to look at is the spread. So again, you're going to just eyeball it, but you're going to eyeball the range or the spread, right, of the distribution. Okay. So we just say, okay, something like, oh, between 10 and 40, right? It gives us an idea of the variation in our ages in this case. Yeah.
So for the spread, what it seems like in terms of sample given, we're just like reading the number of them. Is there ever going to be a time where we're not going to be given, for example, like numbers or something? So no. It's essentially just
you just
reading the bottom.
Look at it and you just say, oh, it's between here and here, roughly. You can, and if it extends a little bit beyond that, that's fine. You can just say roughly between 10 and 40 or whatever values you're given, right? It's just to give an idea, like the scale of what you're dealing with, right? Because if this was between, I don't know, 10,000 and 40,000, right? Then we're talking about a different scale than 10 to 40, right? So it's just to give us a general idea of just how wide our data is, okay? So we just want to eyeball the range of values just to give an idea of the spread. So for this one, this example here, we're just going to say between 10 and 40. Okay. So when you're describing these, between 10 and 40. Okay. I want you to pretend you're on the phone, right? And you've collected this data and you've made this histogram and you're trying to explain it to your friend and they're like, well, what does it look like? Oh, okay, it has a normal distribution. Oh, cool, I know, right? That's great. That's great for your analyses. I know, I'm so excited. The center is around 25 and the spread's between 10 and 40. Oh, wow, that's not very big spread at all. No, I know, really good, right? Click, right? Yeah, so it's just a quick kind of description of what's happening, right? But notice that in order to describe this fully, we have to talk about the shape, we have to talk about the center, and we have to talk about the spread, right? I wish I had saved the article, but I guess the banana is still the fruit of choice for pretending it's a phone. So they did a study where they put out a bunch of fruits. And they're like, pretend you're talking on the phone. Which fruit would you choose? Everyone went for the banana. There you go. That's a little fun fact in LFF. Okay. And I wish I had saved it because I refer to it a lot. Okay, let's do a quick other example. Okay. We'll call, oh, whoops, this guy. I'll get better at this. Histogram number 2. Okay. Here's histogram number 2. So again, I ask you to describe the distribution. So you're pretending to be on the phone, it's in the exam, get your phone out, and you're saying, okay, hey, I got a normal distribution. Oh, cool, yeah. It's centered on, let's say, 30, right? Roughly. But the spread is between -40 and 80 approximately, right? So here's an example where we've got this little limp past 80, but who cares, right? It's just to give a general idea. Oh, the spread's between -40 and 80 this time? Wow, that's crazy. Oh man, everything's dying. Right, so even though we could argue that we have the same distribution essentially, right, and the same center, right, it's not that far off to say that the center is around 25, right? The only thing that's different is the spread now, right? And so the spread, that's going to make a big difference in our analyses. Okay? So for this one, if we have to talk about the shape, we're going to say it's normal. Okay. The center, just to highlight that it's essentially the same as the first histogram we saw, I'll say around 25, roughly. Oops. How about I write that properly? Around 25. And the spread between -40 and 80, approximately, right? Whereas before we had a spread between 10 and 40, right? And so what does that mean in terms of, so if they're centered on the same thing, but we have a spread between -40 and 80, that's huge, right? Versus 10 to 40, that's nice and tight, right? And so what we're saying is that in the second histogram, we have way more variability than in the first histogram, right? When things are nice and tight, right, we have very little variability, okay? And so a lot of stats in what we're going to do this term is going to hinge on the variability, okay? And trying to capture that variability. Any questions? Cool. See you for lab on Friday. Yeah. But I'm just, who's, yeah.
Do you want me to sign up for download the
Oh yeah.
should I come to class?
Let's see. Are you in the 8 o'clock or the 9 o'clock one?
9.
9. Do you have your laptop?
Yeah.
Oh, I keep forgetting to do it, but I have to post that. Yeah. Like a how-to document.
Oh right, yeah.
End meeting.